Selecting your data source is very important. It's better to select data after you've defined what you're looking to measure. That way you avoid over-collecting or under-collecting. Accuracy is always important, but the amount of precision you need during analysis really depends on the conditions of how you'll be reporting your findings. For example, on one end of the extreme, in the world of academic publishing, you're conducting research studies for peer review, so there are more rigorous guidelines for selecting datasets because they care a lot about precision. On the other hand, maybe you're testing out a small data sample and want to do that quickly. Or you're working with the clothing retailer who may want to know a ballpark figure of sales information, just to get a feel for the amount of attention given to each product. For instance, maybe a shift from light to heavy fabrics, such as t-shirts to sweaters, suggests that the season is changing and it affects what people want to buy. That said, keep in mind the context and the conditions of what you're reporting and to whom you're reporting. Here are some things to keep in mind as part of your data selection criteria. Your data contains a representative sample of all the factors you're looking for. You've decided whether to work with purely quantitative data, which is numerical figures only, or whether to include qualitative data, which are descriptions or observable traits that are not easily measured, such as colors and smells. You've decided between primary or secondary source. If it's a secondary source, it's like buying a used car. You should definitely know where it comes from, how it was collected and maintained, etc. A variety of sample methods are used to ensure representativeness by incorporating an element of randomness in selecting data points. Some common ways are called simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Simple random sampling is when everyone in a group are given numbers and placed into a hat. Then Bob randomly picks 2 numbers from that hat and records them. He then returns those numbers and chooses again, which gives the whole population an equal chance of being selected at each draw. Stratified sampling happens when the population is grouped by a characteristic, for instance, age or zip code, and then one person is chosen from each group to make up his team. Cluster sampling is when groups can be made based on a characteristic, like where they live. For example, we can pick one zip code and only look at individuals in that group. In this course, we will be analyzing men's ties, which come in many different styles. By the end of the course, we will have written Python functions that let us easily see how styles and brands are priced, depending on the print and the material it's constructed from. In case you're not familiar, here are some examples of styles available. Popular styles for the prints are called paisley, a droplet-shaped design motif that dates back to the Babylonian civilization, polka dots, dots spaced evenly for a consistent pattern, sporting, logos or emblems printed on the tie, solid colors, a solid spread of color, plaid, a grid-like pattern, striped, parallel lines typically of the same width, differing in color or texture than the surface on either side of it. Along with these styles, we'll also consider fabric and price.